Let me share my screen, and then we are ready to go. So what I would like to show you today is a new project that is about to start. So let's assume we've just signed a contract with a new customer, and now we want to break down the phases and milestones for this new project into more granular activities in Floor2Plan. So therefore, I go to the Floor2Plan website that is shipyard specific. It is therefore a web-hosted environment, so you can run Floor2Plan on any device, a tablet, a touchscreen hanging on the wall, or a laptop, even a mobile phone. And the number of tiles you get to see depends on your role, so the number of rides, so to say, that you have. So much of what we are showing today orients towards new construction shipyards. Even though the concepts are the same, the examples are a bit different. So I would like to emphasize that everything you see can also be used for a ship repair environment, but then the setup is a little bit different. One of the things that are, for instance, quite similar is taking a look at the shipyard utilization as a whole. So therefore, I gladly start with that particular setup so that you at least get to see what the impact potentially is for running a multi-project environment. So if you would, let's say, be a new construction yard now starting to plan out a new contract for the next months or years, then that is essentially the same conceptual setup as when you would look at the dock utilization level of your shipyard. What you see here in front of you at this moment is an example for dock capacity planning. So we have here as organizational units dock 1 and 2. So those are 2 dock slots, and then quay location, shore location. So you get to see in different colors the different individual projects that are taking place within a certain slot. So we, for instance, could see that we have still capacity in dock 1. This is this light blue here, that's all dock 1. So we have in week 29 and week 33, 34 and onwards, we have capacity in dock 1, and a similar setup for dock 2 and so forth. These Gantt chart items here, those represent or reflect actual performance in a running project. So these are the insights gathered from a running shipyard in total. We can also take a look at, for instance, one individual department and see the multi-project workload at this particular time in, for instance, the mechanical department. So also here we see that there is a variety of work for the next weeks, and we also see that they are coming from a variety of projects. So a multi-project, multi-dock location environment, all based on actuals. One step back is moving to the setting of a new project. So let's assume we have a customer just signing a contract for a new ship. Let's call it the webinar ship. And then we are breaking down this project now into more granular activities, because this is an activity that you would maybe currently do in MS Project or Primavera, or maybe even Excel. But you can also start your project here. There are also other scenarios available where, for instance, you would say, well, I have a government customer that wants a P6 schedule. Well, then that would be your starting point. Let's say the first few hundred line items would be covered to run the project in its total in P6. We would automatically read it through APIs, and then we would break it down into more granular detail, all the way down to maybe the 200,000 work packages that ultimately allow you to build your frigate for that government customer. So that 200,000 line item project schedule could perfectly well start here. opening up a project and then selecting from the library, because this is not a new shipyard, this is a shipyard that already has experience, so they know for different types of projects, even though it's engineering to order, different types of projects, they know that there is a different sequence or a different approach to how to handle certain vessel types. Uh, um, and that logic for that vessel type, that is represented here in this particular library. So we are using the library to automate a lot of the planning activities. For this webinar project that I've just selected, let's say it takes us 200 days in production. And we are now using the model as summarized or the library is summarized to break this down into more granular detail. And we see here an application of different milestones and phases. And here in the Gantt chart, I can show you a similar setup because I select here a webinar project. And then this instantly gives me the understanding about, okay, these are the project milestones, the phases, and then all the way from start project to sea trials, everything is sorted here, sorted initially. Because now we are getting into a phase that we are looking into the contract and we are seeing what we actually sold our customer, and we are now starting to recognize that there's need for certain engineering calculations and drawings, and these engineering calculations and drawings, they are also requiring a schedule. So let's assume for simplicity's sake that we are a few months after the signing of the contract and we have a rough understanding of the construction plan. So we know how many hull blocks, for instance, of a certain type we want to distinguish for building this vessel physically. So for that purpose, we are adding blocks. And since we are not a new shipyard, we already know that different type of hull blocks require a different sequence of activities. And let's assume that we have this here demo block, which might represent a mid-body hull block. We call it a hull block 312. And we know from our rough construction plan setup that it will weigh around 50 50 tons. And then we have an internal ratio of 50 man-hours per ton. So therefore, we need to distribute or consume ultimately 2,500 hours of effort in construction or in production in this 84 days of production. What I'm doing now is applying our library for this hull block, and what happens on the back end is that these phases, engineering, cutting and forming, all the way to erection slipway, those are planned automatically, and they are also resource loaded based on that 50 man-hour per ton. So you can see that, for instance, on the erection slipway, completing the complete block, that requires 260 hours of welding from somebody working in the slipway department. So this is a representation of this example shipyard, but if you have a different logic in your yard, we can use a different logic here. If we take a look at the Gantt chart, then we can see that this 312 block is already automatically aligned and positioned in accordance with the start date of the construction phase. And so those two elements are in conjunction. What now happens oftentimes in a normal shipyard is that the engineering activities are broken down in granular detail by the engineering department, and similar like in production, and then you get two different plans. So for instance, in the engineering department, there's a recognition of the need for block drawing, and this 312 hull block drawing is scheduled in a disconnected way, as we saw from the pyramid at the start, in a disconnected way from the hull block itself. So we see here engineering activity for that 312 block. We see a modeling of the block all the way to release for production. Also here, all the resource assignments are loaded with a resource load. So 100 hours required of somebody with a detail engineering trade or certification working in this example in the detailed design department. Could also be a subcontractor, then that would be a different label here. And if we take a look here at the overall schedule, then we can see that the engineering is scheduled after production. Well, that obviously doesn't make any sense. because normally you would schedule engineering as soon as possible and hull block production as late as possible. In order for this to happen automatically, we have introduced a concept that we call relations, or a specific type of relations. And this nature of relation can be added here, which is a component drawing relation. So we are relating this component with this particular drawing. And then we are making a reschedule. And what then happens automatically is that these activities are being made in alignment. So now you see a complete, sensible, logical flow for engineering all the way down to production. This is what you would normally do in an MS project plan, let's say, only with perhaps a bit more detail than you would otherwise see. And then later on, I will show you how we integrate this with the model. Also, in this initial phase, we can start to recognize spaces. So let's assume we have an engine room here, and the engine room will, let's say, erect or exist when we are putting two hull blocks together. And when we do that, we have hot work, conservation, and outfitting activities, which are also now resource loaded. And those activities will make us efficient if we are making use of those time slots to put as much pre-outfitting in here as possible. In order to let everybody know about this particular set of activities, we are adding also a relation between this individual space and this block. So a 312 block is now related to the engine room. This is something that you would maybe today do all from your engineering model, and that's perfectly fine. But through this application here, you can do that a few months prior to the release of the engineering information. So, and that's important time to gain more control about utilization of production in the optimal manner. So it's a trick essentially, and it might be nice to remark that this breakdown that we are adding here now, that is so used of shipyard applied knowledge, that's often to refer to, for instance, at Damen Naval, I know they are referring to this as what they call a logical work breakdown, and that's also exactly what it is. It's making use of logic that is already available in the shipyard, but it's very difficult to accommodate in generic IT systems. In addition to this space, there are obviously also systems on board, let's say an electrical system, and that runs through a variety of spaces. It also runs through the engine room, and when this system runs through the engine room, then in the engine room, there is specific equipment like the emergency generator that is a part of the electrical system. So we are seeing now that the system flow to plan here automatically recognizes that the emergency generator and the electrical system are interrelated. That is the knowledge or the intelligence of the library behind here. To procure the emergency generator, there's a need for certain activities from, for instance, procurement. And to recognize this sequence of activities, we are adding here what we call a order drawing. And the order drawing is, as mentioned, a series of activities made to procure this component. And it entails not only purchasing activities, but also a little bit of engineering. Also here we are adding a relation, and this relation is important to recognize because it makes sure that we, when we are controlling this ship project, that we are not forgetting anything. And this also allows to see the, for instance, foundation plates be positioned in the hull block building phase, the pre-outfitting phase, so that we utilize all the production phases to the optimal extent. If I now go back to this here again chart, I have the ability to take different perspectives. So I can take a look at a hull block perspective. I can take a look at a space perspective. And in the space, I will not only see the space itself, but I also see the emergency generator, the mounting and the delivery of this generator. And on the system level, I can see the electrical system and its relation to the to the engine room and the emergency generator. So at a certain moment in time, we have broken this down into more granular detail as we've done here. And then at some point, that is maybe the point that today you would start making use of model information or engineering model information. At that moment in time, we can actually take a look at the model and say, okay, let's use data from the model, so the bill of materials, for instance, from the model to start enriching our schedule and our plan. And this is what we call a rolling wave method of planning, actually, because now that we have this additional information, we are starting to make use of it in the schedule. So I'm now selecting a hull block, let's say 312 from our example. And then initially, I'm now interested in only the structural steel. So I'm pulling here up the structural steel, and this is the complete block. And then in the block, we have individual units like this one here. So what I can now do is push the sync button. And in this here demo, I will do this manually. I can push the sync button, and when I push the sync button, the system allows me for this webinar project to pull in all the sub-assemblies. So now the sync starts to run. And here underneath block 312, I see the first panels be imported. So let's go to block 312. And I can see here all these individual sub-assemblies. And the same here. So I see now all the distinctive parts, they are coming in from the model here. And the additional value is that individual panels also have an individual set of properties, such as welding length or weight. And we are pulling that information from the model as well. And we are, how do you say that, replicating the impact on schedule. So in other words, we are using the welding length and the weight to determine the exact need of welding hours. And so the resource assignment or assignments to complete this task. So you see here, for instance, mounting or fabrication, and those activities like here machinery on the metal shop, the 5 hours, they are the result of importing the part and then reading the metadata such as welding length and weight. So in the demo example, this concludes, let's say, the work preparation phase. And now I'm interested in taking a view of somebody on the receiving end of this schedule, let's say somebody in the assembly hall. So I'm taking the perspective of the assembly hall lead. And let me first go here to the floorboard, because the floorboard is essentially the home page of the supervisor where he gets a comprehension on running work. So here at the assembly hall where I am the lead, and you can see here in the top right, I am the assembly hall lead. These are the 4 projects that are currently running in my shop. I can also take a look at a different department. Let's say you are expecting certain transport to be picked up, to be picking up your hull block to move to a different location or to move to the paint shop. Then you can take a look here at the transport department and see, for instance, what they have going on this particular day. But for the example's sake, I'm now interested in the assembly hall, and the assembly hall has these 4 projects. So if I look at the shop floor, then I will see all these distinctive panels laying on the shop floor. I'm interested in block 311 and 312. And when I open block 312, I see all the distinctive activities and parts that are consumed in this overall block. So initially, I see here a list of activities. That all consist of this block, but I also see here all the distinctive parts. So there's one assembly, there are 12 parts, there's a foundation in this 312 block, there's a piping work package, and I can also, for instance, take a look at this individual piping work package and see its installment. So on the back end, we have this connection to PDM systems that allow for for this recording to be shown. An overview of what's going on with this particular block. See all the subsequent stages, so the running activities in the middle and the subsequent activities, or the predecessors and the successors in the next columns. And if I take a look at this running work, then I'm also curious as a supervisor or a production manager about where I am with my overall resources. So in this particular resource graph, I can look into this particular week, week 22. This is where we are today, and then the subsequent weeks. And then I can see here on these horizontal bars the capacity line. So these are my own workers. We have a little bit of temporary hires, so that's the additional layer here. That's the orange line. Then we have a recognition of what we call target capacity, which is maybe your break-even point. And then there is a maximum, which can be welding machines in a shop, or the number of people for security or safety reasons. And then here we have, for instance, a total summary of volume. So we have 3 running projects. In total, they require 1,000 hours to be consumed in this particular week. And you also see the subdivision of where those hours should be spent. I can also take a look at a Gantt chart showing me the running work for my shop in this particular week. So what needs to be completed in what week. So you also see the consumption of different individual panels being consumed by that bigger hull block. And this allows me to understand as a supervisor where my priorities need to go in a given week. Subsequently, I'm looking at the plan board, and the plan board essentially is an overview of all the running work. So this is all released to production from, let's say, the office. On the right here, I have my team. So I'm now looking at the welding team here in the assembly hall. And on the left, I see all the different trades. So I'm now interested in looking only at welding work. So if I on the left select welding, then on the right, it will only show me people with the right welding qualification. And this same logic also applies to quality or safety standards, or whatever certification is required. And then you are matching the requirement of the job with the certifications of the worker. And then in the middle is also a selection of welding work. So I'm only seeing released work for the assembly hall in the here and now, which contains welding. And so now I can see on the top that this pillar assembling work requires indeed welding. It's the Wärtsilä demo project. The predecessor is ready, the material is ready, but there's an engineering change that is pending. I also see that, well, this is red, meaning we don't have sufficient workers on this task to be ready in time. This here is orange, means that we do have sufficient workers. But as you can see here in the red and here in the orange, there's a problem with this work. So there's a limitation on task readiness. And I will show you subsequently what that means for finding an alternative scenario on behalf of the supervisor. So this particular plan board now allows me to assign workers to tasks, and I'm selecting now the assembly hall worker, which has a 3 behind his name, meaning he's already got 3 activities assigned. And it's relatively easy to assign workers to tasks. It's just dragging and dropping. And subsequently, if I would be the assembly hall worker, I would pass by the entrance gate in the morning. I would punch in for my shop time, meaning that there's a shift and I'm working on the shift, and the clocking panel requires me to punch in and out, making sure that I have sufficient hours in accordance to my schedule. There's a separate story about how that all comes together, but we have small screens and we have big screens, and the small ones are for the clocks and the big ones is for the hours on the job. And that's what I show you now, because as an assembly hall worker, I'm moving or walking towards the big screen hanging on the wall. I'm using my tag, and instantly I get an overview of all the running work that is assigned to me personally. So this is the work to which I'm assigned. I'm working on 2 hull blocks at the moment, the 312 and the 311. And when I push my finger on the +4, it just writes my hours. I can also see here on the bottom half that yesterday I've punched in from 7:30 to 4. And today, Tuesday, I've punched in at 7:30. And obviously there's no punch out yet because we are middle throughout the day. 4 hours on this activity, and then let's say 4 hours on this one. I can also open up this item here and then see the resemblance of a digital work package, because I can see all the materials involved. I can also see that same spool installation video again, where it gives me guidance on what exactly to go and do in making this hull block, this 311, 312 hull block pipework package be completed. So assigning hours to the job, then I'm finished. And subsequently, the assembly hall lead comes into work in the morning. He will take a look at the timesheets. He will see the 8 hours booked. He will take a look at these hours. He sees, oh, there are scheduled hours, there are worked hours, there are hours being. Oh, sorry, I need to have the other one that's coming here from the assembly hall team. Yeah. So the 8 hours that I've just submitted, and then take a look at the clocked hours against the scheduled hours, and then approve. And when I've approved this daily timesheet, once a week I go to the progress bar, and here I will find the activities that are assigned to me in my shop. Those are all running activities. And now the question is, where are you with your progress? So I can say as a supervisor, well, this one is ready, this one is ready, this one will take a week longer, and this requires 2 men, 2 days, so that's 32 hours, and then we are done. So when I conclude this update of progress, when I am, let's say, a project manager in this particular project, I can take a look at all kinds of reporting. So for instance, in the S-curve will show me a recognition of where I am with this project, maybe in comparison to an individual hull block. So I can also pull up individual hull blocks or systems or whatever I'm interested in. I can make comparisons to similar blocks in other projects, or comparisons with other projects in total. I can take a look at my project KPI, so the earned value, like schedule performance, cost performance, that's all in here. I can break this down into more granular detail to understand where deviations are coming from, and to find root causes for things to go and fix in work that is not yet finished. Same here for department KPIs. And then obviously based on the recognition of progress, I also have an understanding, not as a project manager, but as a production manager, for instance, on where I am with my overall resource utilization. So taking a look at where I am with the yard as a total, and then across all the projects. So if there are deviations in the running project in terms of schedule, then obviously as a project manager, you would want to see where those changes are taking place. So for that purpose, we are now taking a shift to a project manager's perspective. And we are seeing here or red approval buttons. And those red approval buttons, they signal that changes have been proposed to this here project that we need to go and fix. So through the approval button, I can see the running and the new proposed schedule. I can see the proposed changes, and I can either disapprove or approve them if I have an understanding on the impact. So there's here float, there is a critical path, there are all kinds of additional tools, even AI, that helps you to understand not only where you are with the project today, but also the repercussions of further delay towards the future. And if you are in agreement with the proposed changes, you can approve them. And then it will update the data, not only in this system, but also in other connected systems. So this is, let's say, the happy flow from the supervisor onwards. What Sophia showed was a scenario planning. And And I think we are out of time. So if I'm not mistaken, then that is something for next time.